So this next problem we're going to do is a ride from an amusement park. It's called the gravitron. There is a video I posted as well that is just a link to another YouTube video that shows kind of what a gravitron is if you've never been in one. It kind of just shows the ride. So basically what a gravitron is that it is this ride that moves in a circle. Basically, you get in the ride and the sides of the walls are slanted and everyone leans up against the walls. And there is a guy in the middle that's controlling the ride. He turns it on and off, and there's people lined up against the wall. So basically, once the ride starts spinning, you're able to move anywhere on the walls due to this centripetal force that is pulling you inward. So let's say the person is upside down on the wall. Okay, there is the centripetal force that's pulling them towards the center. So F normal is towards the center, provided from the wall that they're laying on. So that's why it's a normal force, because it's a stable surface. Then there's their weight due to gravity. So force of gravity is down, and force of friction between their body and the wall is up. So if the gravitron ride is about, let's say it's about 5 meters, it has a 5-meter radius. I want to know what is the minimum coefficient of friction needed to stick to the wall of the gravitron ride. So we're going to need to know how long it takes for this gravitron to rotate one time, because it's important that we know the speed. We want to know the speed. So in order to know the speed, we want to know the time it takes for one revolution. Let's say the time it takes is 2 seconds for one revolution. So similar to the horizontal motion problem we did, we used the equation velocity equals distance over time to find the speed of the object. So we know that the distance the gravitron moves is its circumference, so 2 pi r divided by time. So 2 pi times 5 meters divided by 2 seconds gives us a velocity of 15.7 meters per second. So now we're curious about what is the minimum coefficient of friction needed. So we're going to need to set up our force equations. F equals ma in the x direction and F equals ma in the y direction. So the y direction, the person is stuck to the wall, so they're not moving up and down at all. So the acceleration in the y direction is 0. However, there is this centripetal force, and the centripetal force here is the normal force, so they are accelerating in the x direction because their speed is constantly changing direction. So let's go ahead and write our equation. F normal equals mv squared over r. And our y equation, we have force of friction is up, Fg is down, which equals 0. So our force of friction is equal to a force of gravity. And we know the equation for force of friction is mu Fn, which is equal to force of gravity, which is mg. And we can use this normal force from over here, plug it in, mu mv squared over r is going to be equal to mg. You'll notice the masses cancel. We're looking for the coefficient of friction, so this is our unknown. So let's go ahead and solve for that. Let's multiply r on both sides. R's cancel. Let's divide by a v squared on both sides. You get mu is equal to g times r over v squared. And when you plug this in, you get 9.8 times 5 divided by, the velocity was 15.7 we found earlier, squared. which gives us about 0.199 coefficient, which is approximately 0.2.